Welcome everyone. Here is one exam question covering 13.1. We're here in an exam from fall 2016, it looks like. Our goal here is to parameterize the curve given by the intersection of the surfaces below. So it looks like we have x squared plus y squared equals 1. So that's going to be this nice cylinder one, and then we have y plus 2z equals 4. So that's the nice plane one here. All right, and then we have a nice hint. Make sure you get the entire curve and don't forget to write down the domain of your parameter. Okay, so starting with this, right, I kind of see it's nice and bold here, right? We have the curve of intersection. And so when I look at this, I see that it's a nice closed curve, right? We have kind of a circle or maybe an ellipse here. And so I think maybe I'm going to use sines and cosines. Moreover, I see this formula right here, the x squared plus y squared equals 1. This really is pushing me to think about what if x was equal to cosine of t, and what if y was equal to sine of t? Because if that's the case, right, then we would have cosine squared plus sine squared equals 1. And that's always true no matter what the t value is. Okay, so here is maybe a good choice for my parameterization of x and a good choice for my parameterization of y, but how do I get z? Well, that's where I need to use this other thing down here, right? So if I go ahead and I solve this for z, I would get z is equal to 4 minus y, and I'd have to divide by 2. So let's divide both sides by 2. Okay, but now remember y, right, in terms of t is sine. So I'm going to go ahead and switch that out. Actually, let me do a couple things. Let me distribute this 2, division by 2. So I'm going to get 2 minus 1/2. And instead of y, I'm going to go ahead and write sine. So sine of t. So here is my x, my y, my z. So if you'd like to put this in vector form, that would look like r of t is equal to, and in the first coordinate, I'd have cosine of t. In the second coordinate, I'd have sine of t. And in the third coordinate, I'd have 2 minus 1/2 sine of t. And now thinking back, right, we had this hint. Don't forget to write the domain of your parameter, right? So in this case, since I'm going all the way around the circle, I would like t to range between 0 and 2 pi to get all the way around the circle. All right, so yes, this would be my final answer with the domain of the parameter. That's all there is to it. All right, so there is one example problem that's shown up from 13.1 on a previous exam. I hope you guys enjoyed. I'll see you out there maybe in 13.2. All right, see you then.